Today I'm going to explain again the SBP question, which is I think very hot, and the concept is very good. So I would like to share again for this question for the second time, because for my first video I actually didn't organize the flow of the teaching. So now let's go through the two functions. Y equal to hx and y equal to gx are two curves, and then the gradient of the function is actually dy dx. So let's have a look at the curve. The y equal to gx, I will use a red color to show you this is so-called the curve. Okay, we can call function, same story, the curve of the function. And then when the x0, g0, meaning that the x0 you substitute into the y, so you get the y-intercept. So g0 means the y-intercept is positive c. Okay, and then for this one is another curve, another function. Okay, it's in blue color. So when I write h0, it means that the y-intercept for the function is negative c, because when you substitute x0 into the function h, you'll get negative c. So obviously from the graph, the y-intercept is negative c, so you write as h0 equal to negative c. That is how you write the function in terms of the y-intercept. Now you are given two straight line touches the curve. When the straight line touches the curve, that is so-called dy dx, or we can write as first derivative as g prime 0. When I write g with a prime 0, it means that dy dx for the function g. Alright, so for both of the curve, the gradient of the tangent actually is 1. You can see y equal to mx plus c. The number in front of the x is 1. So we can say gradient of the straight line, which is so-called tangent, the red line is called tangent, is having gradient 1. So gradient 1, it means that the dy dx at that point is also 1, because all the points on the straight line actually equal to 1. Do you understand? So dy dx is means gradient of the blue line, or we call tangent. Okay, so you can write h prime 0 equal to 1. It means that dy dx at the x equal to 0 for the blue line is 1. So now you're asking to find the first derivative, okay, when x0 for the new function. And the new function is given hx over gx. So the new function is fx, but fx is hx over gx. So now we will apply the principle of the differentiation u and v. Remember, when you differentiate, we always v times du dx minus u times dv dx over the v square. Okay, so we will just substitute the value only. It's actually simple if you understand the question. So the u is referring to the hx, and the v is referring to gx. So when v, okay, we will write g0. When u, du dx, we write h prime, because it's differentiation of first derivative. Then u, you write h0. dv dx, you write g prime 0, because g prime means differentiate. Okay, differentiate the v. Okay, differentiate the v, so g prime v. And over the v square, okay, over the v square, you write g0, alright, square. So that is how you get the answer. Again, I show you f prime 0. It means a differentiation for the function hx over gx, or you can say dy dx, or you can say first derivative is equal to g0 h prime 0 minus h0 g prime 0 over g0, which is a v. Okay, the v is g0. Alright, so then you just substitute the value just now. For the g0, we have the value, right? For h0 also we have 0, right? And then for g prime 0 is 1 and h prime 0 is 1, right? So actually you just focus to the intercept because the h prime 0 and g prime 0 is 1. So it's actually just plug in the intercept for g0, which is c times the 1 minus the h0 intercept is negative c times 1 over the g0 is the intercept, then c squared, right? And then you simplify c plus c over c squared, so you have 2c over c squared, and finally your answer is 2 over c. Is actually not so difficult, right? Alright, I knew that many of you still confused, so I would like to explain again. Given two curves, okay, you are given two curves. The curve given in terms of function hx and gx, and the tangent to each curve when x equal to 0 is 1. So this is the important concept behind the gradient of the tangent, or we call it dy dx. Now please observe the axis x and y axis. I'm showing you a Cartesian plane. I'm going to sketch the curve y equal to hx and y equal to gx on the blackboard. So let's have a look of the curve. So before we really can understand the concept, we must make it clear what it means by function. So this is one of the function. So basically the name of the function, I can tell you example like y equal to negative 2 over x, but here they don't want to mention the exact function. They just use a symbol, then they say this is y equal to hx. So you just accept that this is one of the function, and you have another function. Okay, the other function is y equal to gx, right? So we have y equal to hx that I show you. Okay, so now for this y equal to hx, the curve, or we say the graph or the curly line is cutting the y-axis at one of the point, which is negative, right? So the y-intercept seems like is negative. So that is actually the value of the function when x equal to 0. So when I say y-intercept, I can say the value of function when x equal to 0. Alright, there's another function y equal to gx, right? So this function is denoted as gx. So when the x is equal to 0, you will see there is an intercept. Okay, the blue line here is so-called the tangent to the curve. So the tangent to the curve are the lines that touches the curve, okay, at one point. Okay, for gx, it touch at 0 and c. Okay, for the other curve, for hx, also it touch at one point. So for gx, the y-intercept is c, and the tangent is touches the curve at one point at 0, c. For the curve, the y-intercept is 0, c, so we can write g0, okay, is equal to c, meaning that when x equal to 0, okay, the function is having value of the c. Example, let's say y equal to 3x plus 4. So when x 0, okay, y equal to 4. So you can write 0, 4. Okay, so you can, because the function is g, so you write g0 equal to c. That means the y-intercept for the function g. Understand? And for the function h, so how to write the intercept for function h? You will write h0 equal to negative c. Alright? So example, let's say you have a function, let's say y equal to 2x minus 4. So when x0, y is negative 4, So you can write the function, let's say is hx, you can write h0 is negative 4. So here you can write h0 is negative c. Okay, so I explained to you how to write the y-intercept for function g and function h. I hope you understand. Alright, so now we will explain further. Okay, for the blue line, the gradient is 1, y equal to 1x plus c. Okay, so it means that the gradient at that point also equal to 1 because the gradient for all the points on the blue line are equal to 1. Okay, so you can write g prime 0 is 1. For the other line, also the gradient is the same. And then this blue line is touches at the curve h. So you can write h prime 0 equal to 1. So are you still okay? Are you confused? H prime 0 equal to 1 means dy dx or the gradient of tangent to the curve is 1 for the blue line for hx. Okay, if you can understand, let's proceed from graph. We actually get the information. There are 4 important information. Okay, one of the information is the y-intercept for both curve, right? So you actually can read the y-intercept for gx and hx, right? So you can write down the y-intercept for g. Okay, g0 is positive, right? Positive c. And for h0, the line is cutting at negative c, so you write negative c. So g prime 0 is 1, obviously, because it's the gradient of the blue line. Okay, so it's the gradient of the tangent to the curve. And then the h0 is negative c, right? Okay, so that is the y-intercept for the curve hx. And then the h prime 0 obviously is 1 because the tangent, the blue line is having gradient 1, isn't it? Right? Okay, now since we have all the information, now we can apply here. So we have fx equal to hx over gx, and we are asking to find f prime 0. So let's recall the calculus formula number 2. Okay, the formula looks like this. F prime x is dy dx equal to gx, which is your v. H prime x is your du dx minus u is hx, and g prime x is du dx over v squared. Remember, dy dx equal to v du dx minus u dv dx over the v squared. So this is a formula calculus number 2, the quotient law of the differentiation. So please recall the formula because you have learned in terms of the dy dx equal to v, okay, du dx minus u dv dx over v squared for the function, okay, u over v. So now we just substitute the 0, okay, g0, h prime 0 minus h0, g prime 0 over z0 square. And now you just substitute all the information into the curve, and then you will solve the function, okay, the f prime 0. So we have actually have all the values for g0, h prime 0, h0 and g prime 0, right? Okay, now for g0 is c, right? It's the y-intercept for the function g, alright? And then for h prime 0 is the gradient of the tangent to the curve, right? Okay, for the curve hx, the blue line, remember the tangent is having gradient 1. Okay, then we have to minus. h0 is the y-intercept for the graph hx, right? It's negative c, isn't it? It's a y-intercept. for the function h. And then g prime 0, as I say, is the gradient of the blue line, which named as the tangent to the curve. And both tangents are having gradient is 1. We say dy dx x0 equal to 1. So, okay, so when you see prime, that means dy dx. Okay, so it means the gradient of the straight line touches the curve. Remember, this is very important concept, right? So the gradient of the tangent is 1, and you have to divide by v square. V square is the z0, is the y-intercept for the function g, which is positive c, right? So you have to square it, and then you simplify the answer to the simplest form. You will get the answer, which is, let's simplify the answer. So you have c times 1 minus negative c, right? So it's actually c plus c over, okay, c plus c will be 2c, right? 2c over c squared. So finally your answer is, you cancel out one of the c up and down. So your answer is 2 over c, right? This is the final answer for this question, even though it's very hot, but the concept behind this question are very, very important. So please go through my video teaching many times if you don't understand. So okay, till then, I shall see you in my next video teaching. I really hope that my sharing will help you to understand the concept behind the differentiation. Bye bye and have a nice day.